Okay, so let's use our inverses in order to solve some problems, right? So we're going to use our right triangles, and we're going to use this for acute reference angles only, and they have to be non-quadrantal. Remember, quadrantal are your, 90 degrees, 180, and so forth and so on, okay? So here's our example directions. We are going to find the exact value of each expression. Okay, so here's our first problem. We are going to find sine of the inverse of cosine of 1/4. Okay, so for a problem like this, right, it seems kind of challenging and difficult. What I want to do is I'm going to write a let statement. I'm going to say let theta equal the inverse of cosine of 1/4. And if I do that, then this will just become sine of theta. And that I know how to get around. So for this problem right here, what we're going to do is kind of what we were doing in previous problems. We're going to kind of switch things around. So we're trying to figure out cosine of what will give me 1/4. Okay. So notice that the cosine is positive. So again, this takes us back to the table. We're only looking at the first and the second quadrant. So cosine for 1/4. So again, I draw a little right triangle here. And we have to remember cosine is made up of x over r. That's nothing new. So here's our x. We would say 1. And here's our r, which is 4. We are then going to use x squared y squared is equal to r squared. So 1 plus y squared is equal to 16. Y squared is equal to 15. Y is plus or minus the radical of 15. Now, it's important to know, we made cosine in quadrant number 1, which means if that's quadrant number 1, sine should also be positive. Okay, so coming back to our original problem, so this will also be quadrant number 1. And so sine is made up of y over r. So I will be able to say that this guy is going to be the radical of 15 all over 4. So how I can actually write my problem out is I can say the sine of the inverse of cosine of 1/4, right, is equal to the radical of 15 over 4. So this is how I would write my whole problem out. Okay, so really the only thing new is kind of like this little let statement right here, where we're going to kind of change the way something is written. Okay, let's try another one. So same directions, find the value. And so here is number 2. So we're going to say the secant of the inverse of sine of negative 1/5, close and close. Okay, so again, the first thing I'm going to do is I'm going to get rid of what makes it scary, is this. So I'm going to say let theta, or whatever you want it to be, equal the inverse of sine of the negative 1/5. And because I get to say that, I now have this expression. And again, I just want to figure out what that expression is equal to. All right, back to this problem. I'm going to switch where things are. So I'm going to say the sine of theta is negative 1/5. So again, I'm only dealing with either the first or the fourth quadrant. So because it's negative, I know I'm going to be dealing with the fourth quadrant. Here's my fourth quadrant. So negative 1 is my y value. So y over r. Here's your 5. I'm going to come back and we're going to say x squared plus y squared is equal to r squared. All right, so x squared plus negative 1 squared is equal to 5 squared. So x squared is equal to 24. X is equal to plus or minus 24. Again, break down 24 into 4 times root 6. So this is really plus or minus 2 root 6. We are in the quadrant number 4, and x is positive in that quadrant number 4. So we are really going to say that it's a positive 2 root 6. But that's not what we're trying to find. We're trying to figure out what is the secant. So secant is made up of r over x. So that means that it is your r, which is your 5, over your x, which is 2 root 6. Let's go ahead and rationalize our denominator. And so I'm going to get 5 root 6 all over 2 times 6, which gives you 12. So this means that the secant of the inverse of sine of negative 1/5 is going to be this lovely fraction, whatever 5 times root 6 over 12 is. Okay. All right, so let's see if we can make these a little bit more challenging, right? Not that we want to, but sometimes we have to. So in the previous chapter, we learned all about double angles and half angles and sum and difference. So let's see one of those right now. So cosine of 2, I'm going to write it like this time. I'm going to say arc sine of 1/4. Close, close. So again, this kind of looks a little scary, but again, I always want to just get rid of whatever the inverse is. So I'm going to go ahead and I'm going to write a let statement. I'm going to say let theta equal this inverse. So arc sine of 1/4. So because I get to say that, I now get to say that this is cosine of 2 theta. Hopefully, what you recognize is that that's your double angle. And there are 3 ways that we can write it. We can write it as cosine squared of theta minus sine squared of theta. We can say that this is 2 cosine squared of theta minus 1, or 1 minus 2 sine squared of theta. So we have a lot of different options to work with. Okay, so looking at our problem, let's go back to my inverse. So let's rewrite this. So I'm going to say that the sine of theta is really equal to 1/4. Well, if I'm trying to choose the path of least work, that means I'm going to use this equation right here. All right. So let's go ahead and plug it in. So there's no work that I necessarily need to do. So I'm just going to say that this is 1 minus 2 and then 1/4 squared. So 1 minus 2 times 1 over 16, the 2 and the 16 cancel off, leaving with 8. So 8 over 8 minus 1 over 8. And so my answer should be 7 over 8. So again, I get to say that the cosine of 2 arc sine of 1/4 is equal to 7 over 8. Now, could I have used Pythagorean theorem and figured out the rest of my answer? Absolutely. Right? But again, you want to use, you want to be able to use any of your 3 equations for the double angle, especially if you have them. All right? Let's try one more. This time, let's use a sum and difference. So example number 4. So I'm going to say the sine of arc sine of 3/5 plus arc cosine of 5 over 13. Okay, so this one's a little bit trickier, but hopefully what you recognize is that we're taking something and we're going to add something. So this time I'm going to write 2 let statements. I'm going to say theta and alpha, right? So I'm going to say let theta equal the arc sine of 3/5. And then over here, I'm going to say let alpha equal the arc cosine of 5/13. Okay, so if I did this, right, this is like saying the sine of theta plus alpha. So using our sum and difference, this would be like saying the sine of theta cosine of alpha plus cosine of theta sine of alpha. So we have to figure out what we know. All right, let's come back over here. So, oops, get rid of the arc symbol. So I'm going to switch things around. So this will be sine of theta is equal to 3/5. Well, that's exciting news. I have this guy right here. If I do this over here, I have cosine of alpha equal to 5/13. Wonderful. I got those two taken care of. I still need to figure out what the cosine of theta is. Again, what I'm going to do is I'm going to use y over r. Hopefully, again, you recognize this Pythagorean triple. So 3 squared plus x squared is equal to 5 squared. X squared is equal to 16. X is equal to 4. Notice that it's positive, so that must mean I'm in quadrant number 1. So that means that the cosine of theta should also be in quadrant number 1. So it'll be 4 over 5. So again, I have this guy now. Over here, I'm going to do the same exact thing. It's hard to see that this was a 5, so I'm going to rewrite that. There we go. So again, here is my x over r. So again, 5 squared plus y squared is equal to 13 squared. So really, this is 169 minus 25, so 144. Y is equal to 12. Again, we're in quadrant number 1. If that's in quadrant number 1, this will also be quadrant number 1. Which means that this will be a radical, not radical, erase that radical symbol. So this will really be just 12 over 13. So now I got that guy taken care of. All right, so let's plug in what we know. So I'm going to rewrite this. We're going to say that it's the sine of theta cosine of alpha plus the cosine of theta sine of alpha. So what do I know? I know that the sine of theta was 3/5. I know that the cosine of alpha was 5 over 13. Cosine of theta is 4 over 5. And the sine of theta was 12 over 13. All right, we'll go ahead. We're going to multiply this together. So 3 times 5 is 15. And then 5 times 13 should be 65. And 4 times 12 is 48 over 65, which altogether should be 63 over 65. Okay. So again, we're trying to figure out, using our previous knowledge and knowing based on this chart that we've seen earlier, kind of what quadrants we're always in. Again, if it's positive, chances are it's in the first quadrant. If it's negative, it will either be in the second or fourth quadrant. Okay. Awesome. So let's try one more type of problem. What happens if we're actually not given any numbers? So write the following as an algebraic expression in U for when U is greater than 0. So here's our first one. So tan and then arc cosine of U. I'm going to do exactly the same thing. I'm going to say let theta equal arc cosine of U. So cosine of theta is equal to U. How exciting. If it's U is greater than 0, I know I'm in quadrant number 1. So if I set this up, quadrant number 1, right? Here's my right triangle, U. So this is like saying U over 1. So 1, U. So this is where it gets kind of confusing. So U squared plus Y squared is equal to 1 squared. So Y squared is equal to 1 minus U squared. Y will equal plus or minus the radical of 1 minus U squared. We don't really know what that is, so we can kind of just leave it alone. Again, we're in quadrant 1, so do we need that plus or minus? No. We know it's already positive. So this means that this guy right here, we want to know what the tangent of theta is. Well, tangent's made up of y over x. So here's my y, here's my x. So that means that the tangent of the arc of cosine of U is 1 minus U squared in the radical all over U. Bam. So again, we can totally do these with other problems. Look for hints. So like if you see the secant and then the inverse of the cosine U over U squared plus 5, right? What you're going to notice is that these are reciprocals of each other. So this answer, if we tried working this out, would just be U squared plus 5 and then all over U. right? So try working that problem out and see if you see if you get that as your answer.